Hey guys, Laird here, and today I wanted to share a small project that I was working on just today in my free time, and I have it here right here, so I'll show you the result first, and then we will get to the tutorial part. So what I hold in my hand in this small project that I quickly set up is a paint gun. So I can hold my left mouse click, and I paint. Okay, and you can see that these are particles and they stay on the surface. And it works for the walls, it works for nearly everything. There are some issues with the floor, and I will explain later why, but basically what you can do is you can paint various patterns and stuff. And then I have a different mode for this paint gun, which is just shooting a lot of particles, and I'm gonna show you right here the result of it. So this is kind of crazy. There are like I think around 50,000 particles spawning per second, but the performance should be fine actually. And you see the funny thing about it is that it kind of obstructs the cubes, so you get this pattern on the wall. It kind of feels like the same technique that you would do with the path tracing when you trace the photons, and it dissipates after some time. So I set there like 20 seconds limit to the lifetime of these particles. So the applications are like various. You can do whatever you want there. Maybe some kind of paint mini game or something like that. I will explain later the limitations of this, but if you're interested, let's get to the tutorial part. So I'm just gonna move this away, and I'm gonna go to the Unreal Create New Project browser, and let's just start with the first person template, create project. And I'm using 4.12.5, but the engine version should not be really important here. It should work on nearly everything. Okay, so let's get started. Now first, let's take a look at what we have here. I'm gonna change the folder structure. No, not change, but let's just examine the folder structure a little bit. So this is our character. I have the blueprint opened right here, and this is the logic which fires when you press fire button, which is set to the left mouse button. It plays the animation and then it shoots the projectile. We don't want to shoot the projectile. Actually, we don't want to play the animation. So we'll have our own code there. So how does this painting thing works? Well, I actually got inspired when I watched the recent Epic Games Unreal Engine stream about particle collision. So I'll make a particle emitter here, make a new folder, let's call it particles. You don't have to make the folder, of course, it's just a matter of managing your assets properly. And here we'll make particle system, and we will call it GPU particle collision. Okay, we made it, we open this. Okay, so a couple of things that we need to prepare. We need a material for this particle system. We call it Paintgun particle material, for example. Okay, we open it. So let's make it really easy. Let's make just a sphere sprite for our particles. So as it is a particle, it's unlit, and we put it to masked. Masked is cheaper than translucent, and it can still have the opacity mask. So that's good, more than enough for us for now. So how do we procedurally generate a sphere? Well, first of all, let's take a texture coordinate. And I explained in some previous tutorials what is texture coordinate, and you can also find it in Unreal documents. So let's not dive into this right now. We have a sphere mask here, and then we will add a coordinate 0.5. If you add it like this, and you have a vector 2 coming from here, which is texture coordinate, it outputs in R and G, or X and Y. You put it here, this will be replaced basically during the computations. It will be replaced by vector 2. It will be replaced by this vector. Okay, so 0.5, 0.5. So if you have a vector which has the same values for x, y, z, and w, or x, y, and z, or x, y, you can just put there one vector which is float, and it will have the same effect. So if we click on this node now, click start previewing, we will get this perfect sphere. And let's, oh, actually not, we won't, because we need to set a radius to 0.5. And here we go. So you can see this is a plane, or we can get it on a cube, for example. And we get this perfect crisp sphere. Let's not make it crisp. When we have a sphere mask selected, let's put the hardness to 0. You can learn how the sphere mask how sphere mask works on the Unreal docs once again. Let's not waste time here explaining it. So actually, yeah, I thought about the fact that we are using masked material, so there's no point in making it not perfectly hard or perfectly crisp. Put this to opacity mask, and then we do something else, which is we take particle color, because we were using this material in particles, and let's see, we put color here. So the color which we set in the particle emitter will be the same color that we have here. And then let's multiply alpha of particle color on this, our sphere mask, and put the opacity mask. This is in case we alter alpha in our particle emitter, which we will. Okay, so we have a material ready. Let's get back to our system. And first thing we want to do, let's just switch it. We go right click, type data, and we switch it to GPU sprites. GPU sprites are particles which are calculated on GPU only. It has its own limitations, but it has also the upsides to it. And you will see in a moment why. Basically, you'll see right now, because I'm just gonna put there like 5,000 of those. And now you see there are a lot of these. Let's make it a lifetime much bigger. So the lifetime will be from 5 to maybe 8 seconds. When you say from 5 to 8, it will basically vary for each particle. It will take a random number from 5 to 8. Now you see we have a problem. As soon as we don't look at the particle emitter, as soon as it disappears from camera, all particles disappear. And it's because we don't have fixed bounding boxes for GPU particles. So we click here on an arrow, we say set fixed bounds. Okay. Now the situation is better, but if you put this in the world, you will see the issues, and we will do it right now. So let's say that initial velocity for this particle emitter is actually something more simple, so it's constant. Let's say 500 0. Okay, and maybe this is good enough. Save. Okay, so now we click find in content browser. We get back to our level. We have content browser. This is our particle emitter. We put it on the level, and it's gonna spit its particles. And you see the problem that, yes, it still disappears after we go far enough in our camera, so the camera doesn't see the particle emitter. And the reason for this is that the bounding box is not big enough. So click on the empty space here in the particle editor, and we have here bounds. It says fixed, use fixed relative bounds, and let's see. Let's look at the size. Let's give it a really big size. And remember, we don't have any other performance-heavy stuff in our project, but if you have in your project, you will have to compromise on this stuff maybe. So 5,000, 5,000, 5,000. It's kind of big now. So now if we go back here, you can see that I can be really far away, and I still see the particles going through. But of course, it's not as interesting. So let's add a couple of things. First of all, let's make sure we're using actually our new material that we use. So we have this pane. Oh, actually, I misspelled it. So let's change it. I will go back to the content browser and call it paint. Okay. So now it's selected in the content browser. If I go back to the particle system and I change the material on the particle, it's gonna compile the shader of the material once again. And now you see we have our particle going here. Nice. You can see that it kind of roughly appears here, and it's not a big deal. The reason for this is that we're using masked material, so it cannot be half transparent. But that's the compromise for the performance. Now it doesn't really matter. You can make it translucent. Okay, so let's add here some more variations. So we have a location sphere. Okay, So the sphere will make sure that your particles spawn in various locations on this like spheric form. Okay, so we save it, we get back, and we see that this stuff is a little bit more interesting now. But of course, it's not what we're looking for. So why was the thing that you saw in my project actually painting? Well, it turns out we can actually add collision to the particles. So collision, right mouse button, collision, collision. Okay, so it says scene depth collision cannot be used on emitters when opaque material. Okay, so when we are using scene depth, and I will cover scene depth and the other way of doing collision for the particles in this tutorial, then we need to use translucent materials. So you can take the same input for the opacity mask, put it into opacity, and change from masked blend mount to translucent. Save. Okay, go back here. Now it works. You see it doesn't give any error message. And it says collision mount scene depth. This is okay for us. And what happens upon collision? We keep it default for now. Bounce. Okay. So now if we have our emitter kind of rotated, you can see what happens. And you can see it slowly dissipates now. And the reason for this is now we have a translucent material, so it can be half transparent or something like that. Okay, so let's get back to the rotation. Okay, I'm just going to save everything in case. So what are the issues with the scene depth? The issues with the scene depth are also very well covered in the Epic's live stream. Is that if you don't see the particular surface which should be colliding with the particles, if you're behind the surface, this information is not on the GPU. So the GPU doesn't have this information in its buffers, and because GPU is calculating all the collisions, you can see it will just clip through. And if I don't see this basically surface, then the particles will just go through. So that's not what we want. And if I don't see that surface, well, I will see one of those surfaces, so it will be colliding with this surface. Okay, but we will solve this in a minute. For now, let's make it so you can actually paint. So upon colliding with the surface, let's not bounce, let's stop. Okay, save. We go back here. Now you see they stop. So I'm going to demonstrate what actually happens. I'm just going to go like this. You can see that they are actually on a surface now. That's nice. So let's go back to our particle emitter and make them smaller. So initial size, expand all. We have vector uniform. Let's make sure that it goes from like 2, and Z doesn't matter because it's a sprite, so from 2 maybe to 5. It's going to be 0, it doesn't really matter. Okay. Now they're smaller. Now you can see that they kind of paint on the surface. And of course, the important part here is that their lifetime should be big. So let's make it like 30 to 50. And keep in mind, this will spawn around 250,000 particles in general. So you're not interested in making this possible maybe in a production project, but I'm not sure. And of course, you can optimize in other areas. But okay, you will ask me, okay, we make this particle emitter fine. How do we shoot it? Sure. So I'm going to show it right now. We go to the viewport of our first-person character, and it's in first-person BP blueprints. And this is a list of the components we have. Now, let's add a new component, and it's going to be a particle system. Okay, it's spawned in the bottom of the list. Okay. We choose a template for now. GPU particle collision system. We click on it. Now it's here all the time. Okay, now the problem is, of course, that it collides with us as well. It doesn't really matter for now. Let's change one thing really quickly. Go back here to the sphere, and let's make sure that the sphere radius is like 5 maybe, and the size of the particles is even smaller, maybe from 1 to like 3. Okay. Nice. now it's not that interesting. We will change the pattern of particles a little later on. So now what we want to do is we want to bind it to our gun. So we click on our gun, it's FP gun. Don't confuse it with this gun, this is for VR projects. So we have FP gun. We carry this over to FP gun to attach it to FP gun. And now what happens, you can see that the particle emitter will be moving with FP gun. Okay. So now what we do is we put it in the front of our gun. Okay. And let's change the snapping to like 5. Okay. And now if we play, you can see that it works. And we kind of paint, but there are issues. You can see that it stops in front of a surface. It makes this kind of volumetric, it has this volumetric appearance. Yeah, let's remove the one from the level. So we don't need this one now. Okay. Because for some reason this will be automatically spawning the particles. Okay. So let's make it a little bit more interesting. Again, initial velocity. Let's make it uniform, and we will have like 900 to 1500. Okay. Maybe even like 1200 to 1500. Okay. And now we add some variety, maybe like from max of 50, 50 to minus 50, minus 50. So it will have more kind of spread. Or, okay, let's make it even like 300, 300, minus, sorry, 300, minus 300. Nice. So we go back here. So now it has more spread. And depending on the power of your GPU, you can make a lot more of these particles spawning. I will make twice more, maybe, so it's 5,000. Okay, well, I will actually do thrice, so I'll do 15,000. Okay. You don't have powerful GPU, you don't have to do this, obviously. Now you're just running around, spawning your particles. Okay. And again, we noticed some limitations for the scene depth kind of collision for the particles, and we will fix them quite soon. But before that, let's make sure that you're actually like using it as a gun, so you can start or like you can stop firing it. So let's just take this node input action fire out of it. And when you press it, what will happen is that this particle system will activate. And by default, let's go to its settings here. By default, let's make sure it doesn't auto-activate. Okay. So now we carry it around to the event graph. We say activate. Okay. So whenever you press, it activates. Then whenever you release the mouse button, it deactivates. And what's cool about deactivation, activation, that whenever you do activation or deactivation, it doesn't kill the already alive particles. So it starts or stops spawning new particles. So now it should be fine. Play, it's all fine. Boom, boom, boom. You can see that it collides with the gun, so it has these particles floating in the air. Okay, now there are reasons to use it this way, but we have different way of telling GPU how to calculate the collision, and that is mesh distance field. So I'm just gonna go ahead and go to edit project settings, and we have rendering. In rendering we have lighting. It says generate mesh distance fields. So let's enable this right now. It will say restart your level. Restart the editor. So make sure we have everything saved. I say Control S, and I restart the level now, the editor now. So using mesh distance fields has its own limitations. Let's restore all the assets. Okay. So what would happen for you right now? I'm just gonna carry them around here. What will happen for you right now, probably, if you never enabled mesh distance fields before, you will have calculated mesh distance field appearing right here. It will calculate mesh distance fields for all the meshes that you have on your project or on this level. Just wait for it. Let it calculate those distance fields and then continue. So I have already calculated everything, so I can just start. I can go to my particle emitter. In a collision, I can change collision mount from scene depth to distance field. Now it's gonna make this weird appearance here because mesh distance fields are not present in this preview. Just don't mind this. But when we go back to the level, we can click play. You can see that a lot of things improved actually whenever you shoot it on the cubes. So what happens is you can see that particles cover the cube pretty nicely. Okay, and we go to bigger cube. And of course, you can just adjust the velocity for the cube to make sure, for the particle emitter, sorry, to make more refined paintbrush, so to speak. So you can go in emitter and make sure that we have like maybe we go back to 70 and minus 70. Oops. Yes. Oops. Sorry. Okay, we get more crisp brush. Okay, now there are some issues. You see it calls through here, and there are more issues here. You see it doesn't work here, it doesn't work here. Now, let's talk about this calling thing. You can go and click in your viewport show. You can go to the visualize, and there is mesh distance fields. Okay, now mesh distance fields are kind of way of telling GPU and keeping on GPU the information about kind of the mesh depth on the scene. You can find more theory in Unreal Docs, but the point that we want to have here is that you can go to any static mesh, and of course it doesn't work with BSPs. So you go to any static mesh, you click Ctrl E, which will open this particular static mesh in your mesh editor, and in the details you search for, actually you can go to build settings, and you have this distance field resolution scale right here. Okay, so if you look at the mesh right now, you see that the distance fields is kind of weird and low. It's kind of low poly actually. So I will crank this resolution all up to 3 and click apply changes and save. It's gonna build the distance field again, and you can see that now it looks better actually. There are still some weird things here, but it is an improvement. So we have 3. Yes, okay. So if we go and play now, we'll still have issues, but they are now not as apparent. And this is the downside of using distance fields. Now, the upside, of course, is that it doesn't use scene depth, so it will always properly clip through things, probably collide, even when the camera is not looking at this particular place where you send these things. So you go back, they properly collided. So why doesn't it collide with this stuff? Well, the thing is that distance field works weird and not proper when the scale of the particular static mesh that you're using is not, I don't remember the word, but it's different for different axes. So you can see 1, 40, 60. So what I'm gonna do right now is I'm gonna just go to use defaults to have proper rendering. I'm gonna remove 3 walls right here to make it possible to paint on this wall. I'm gonna make this wall 6 by 6 by 6. Actually, okay, let's go 40 by 40 by 40. Okay, and we have this big giant wall. And if I put it right now, it has proper scaling, which is very big. Now you can paint on it. Let's see. Actually, there are still issues because it's really big now, and the distance field for it is big as well. So let's put it like 20, maybe 15. Okay, 15 should be fine. And I will change the snapping to 100, so I can just move these things more easily. And let's make a couple of those walls here. The main point is that your static meshes have I don't remember the word. I would say universal scaling, but whatever. And the point is that you have those 2. I'll just make 2 walls. I don't care about 2 other walls here. And if we now play, There are these weird seams. Don't mind these guys. No, they still clip. Well, they don't clip here, so I don't know what's up with these parts. Yeah. Okay. Let's just assume it works. Well, it doesn't work here. Yeah. Maybe if you increase the distance field resolution even more, it would work. But yeah, the main point is that don't really scale up your meshes too much. You can see for these walls, this wall actually, yeah, it should work on the center at least. Okay, this works here. On here, it will be more clipping through, but on the center, it's fine. Yeah, so now you can paint. You cannot paint on the floor because the floor is stretched really. So there's a downside there. What I would do is I would take this particle emitter, find a contour browser, duplicate it. So we have two, open the second one, go to collision, change the collision back to scene depth for the second one, save, go to first person character, viewport. Okay, now we have this particle system, let's duplicate it as well. We have like, let's not even rename it. So again, it's not activated by default. And let's just use right mouse button. Right mouse button. So when you press it, what happens is the second particle system is, well, I can just like Control-C, Control-V, activate, deactivate, this guy, okay. So now we have two particle systems and we have two different ways to paint. We have distance fields, which work not always for big meshes. They work really well for these ones though, and you can see they don't add too much extra spacing. And the second option is a right click. It's scene depth. Oh, that's weird. Why wouldn't the scene depth work here? Let me check. Yeah, oops, that's my bad actually. Because we didn't change the particle system here. So go to second one, make it second one. And now for the right click, it's scene depth. So you can see it just goes everywhere. For the painting, it's better to use distance fields with proper meshes. So make sure you have proper mesh size and it's not scaled too much. Maybe has high resolution or something like that. Okay. So both methods have downsides. With high resolution distance fields, you use much more memory, but it's still kind of productive. Kinda. You can use it a couple of different ways. So now let's just talk about making the material more interesting, like slightly more interesting. I don't want to make this tutorial too big, and it's already too big. So instead of having emissive color going from particle color, let's do something else. So we have this input for the particle materials, which is particle random, and it's a random value from 0 to 1 for each of the particles that has this material right now. What we will do is we will use this hue shift, okay? And let's feed it 3 vector, which is the usual RGB color. Start with the red. This is a texture. Okay. And we put this particle random value here. What will it do? It will shift the hue of this color, red, by random value from 0 to 1 as a result. So let's see how it works. Okay, that's exactly what I wanted. So now we have this nice kind of rainbow colored mess, and you can play around with it. Not on the floor. Or you can use the right mouse button and put it anywhere you want with a scene depth. Okay, a couple of other weird things you can do. Let's get back to material. Where was it? Yeah, here it is. Sorry. Let's make it glow slightly, of course. Everyone loves some neon glow. Just multiply it by 5. Now it glows. All right. There we go. Or you can use this method, of course. All right. One other thing is that you can make it kind of random color. It's not the best way to randomize and to switch color, but you know, we can just stick to it now. Let's add to the random value current time. So we add time here. Hue shift percentage here. You see what happens? We go back here, we click play. And now we have this mess with changing colors. Fun. Okay. So ideally what you want to do is you want to actually, let me just try and increase the resolution even more. Apply changes, make sure it calculates. Okay, save. And let's see how would it look like. So visualize mesh distance fields. Okay, now it looks much better actually. You don't want to go so high with the resolution of the mesh, of course, but for the sake of this example, I would do that. And now the situation should be better. Yes, it is better. It's actually much better now. So you can paint very well on the walls. They won't even clip on here. So you can play around with this kind of painting thing. Couple of things I would do probably is maybe alter the spread of this thing to make it work better and optimize the lifetime of this thing. Now, as far as the game application goes, you know, can you make this in production? First question, of course, does it work online? Can you paint with your friends together? Maybe make some kind of cooperational game. This is kind of really hard to do. First of all, obviously, you cannot replicate out of the box the GPU particles, and considering the amount of those that we have here, that's going to be a real challenge to do. So what you would probably want to do, you want to store like gestures that people do, and make sure that your particles have minimum random parameters. So if I just click escape, I go back to my particle system. The velocity should be really like specific, like constant, not uniform. Because what you will have is you will have different people on different computers with a server, and server will basically tell every client what angle is the camera rotated in the current frame, what user is painting. You will only see what user is painting because the server will be reproducing the actions of one of the players on your client. So you want to make sure that the physics plays zero. I think it's called non-deterministic physics, non-deterministic effects. So you want to make sure that if the server launches on your client a particular amount of particles in the direction, they will land exactly where the clients, the other guy had them landed. So that's, you know, you painted the same thing that the other guy sees. So this is challenge all in itself. The other, of course, question will be, okay, can you actually work with some kind of logic that will see that the user painted something and do something in the blueprint or in C++? This is another thing that's hard to do actually, because GPU particles don't produce any collision events because they're just calculated on GPU. So of course you can dive into that. If you have any thoughts, any ideas, I would be happy to discuss them with you in comment section. And yeah, thanks for watching. I was thinking that, you know, this kind of small, I wouldn't say discovery, but inspired by the Epic livestream exploration into maybe some kind of experimental painting stuff in Unreal could be interesting for some of you guys. And I will make more tutorials about blueprints and maybe synchronous execution and blueprints and during the next week. So stay tuned for that. Thanks for watching, and bye-bye.